Okay, so it says, consider this picture of revenue over 3 years. So first I look to make sure that it is actually over 3 years, and it is. Which of the following is a true statement? Revenue in 2013 was approximately 1/7 of the total revenue over the given 3 years. The above picture is not a histogram. Okay, I know that that's true, but I'm going to keep reading just to see. Revenue was greater in 2011 than were the next 2 years combined. Oh, well, that's not true because 100,000 plus 95,000 would be 195,000, and that doesn't even go up to that. Revenue in 2012 was approximately 2/7 of the total revenue over the given 3 years. Well, actually, just looking at the numbers here, this is not going up by sevenths at all. So that's not true. So that means that this probably isn't true. Revenue dropped approximately in half from 2011 to 2012, and then approximately in half again. No, that's not true, because if it was half, then half of 110,000 is 55,000, and we don't even have that on our graph here. So that's not true. So it is, the above picture is not a histogram. And I knew that because these are not, you can't have years on your quantitative variable line like this. So this is not a histogram. This would be considered a bar chart. Which of the histograms below can the box plots correspond? Okay, well, I already know that this weird bar here would not be a histogram. Plus, it doesn't even start at 0 like the box plot does. So it's not A. I'm thinking it's probably B just by glancing, because I know that between 10 and 50 and 10 and 50 on here, there is a large span, like a large area where I have a little bit of data. So that means that this is 25% of my data. That's all from 10 to 50, which would make sense here. And then I have a lot of data between 50 and 60, which I do have a lot of data between 50 and 60. Remember, the shorter on the box plot, the more data between a shorter span. So it means shorter on box plot would equal a taller bar on histogram. So you might want to write that down in case you need to remember that. So I know that's definitely not it, because that would say that I have a lot of data in the front between 0 and 20. Yeah, so looking at the rest of these, I can tell these are definitely not it, and this is definitely your answer. So your answer should be B. Using the most commonly accepted definition of outliers, a set has 5 outliers. If every value of the set is increased by 20%, how many outliers will there be now? There will still be 5, because outliers are outliers and they're always going to be there. All right, this one says, given these parallel box plots, which of the following is incorrect? Set A may not be symmetric. That's true. Even though it looks like it could be symmetric, the actual histogram might not be symmetric. So that's not true. Set A may have 100 times as many values as set B. That's also true. Because just because my box plot looks small doesn't mean that I can't have 25 values of 10, 11, and 12, and another 25 values from 12 to 13, and another 25 values equaling all up to 100. So that can totally be right. The interquartile ranges are the same. I don't know. So let's see. This one would be 6 minus 4, which equals 2. Okay, this one would be 14 minus 12, which equals 2. So it's not that one because that one's true. Both sets are skewed to both lower and higher values. Both sets are skewed to both lower and higher values. I don't even know what that means. So I'm just going to go to the next one and see if the next one's true or not. The ranges are the same. Well, let's see. So we have a max over here of 8 for this one, minus a minimum of 2. So that'll give me 6. And for set A, I have 16 minus 10, which also gives me 6. So that's true. So I know that whatever I didn't understand, that's the incorrect statement, which is probably why I didn't understand it. All right, given this histogram and using the most commonly accepted definition of outliers, what values would be considered outliers? Okay, so this one's kind of tricky because they're using these boxes to help us figure things out. So I'm going to use these boxes that they give us and counting where my median is, where my Q1 is, where my Q3 is, because that's what I need to find outliers. Remember, to find outliers, I need to do 1.5 times the interquartile range. And then whatever number we get, we add it to Q3 and we subtract it from Q1. So let's figure this out. Let's count how many bars there are first. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so there are 16 boxes. So I'm just going to pretend like my sample size is 16, let's say. And so half of that would be my median. And so let's count out 8 boxes. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So that puts my median at 80. Just want to make sure that the other side has 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. So now I need my Q1. Half of 8 is 4. So now I can say, okay, if I count out 4, so there's 1, 2, 3, 4. So my Q1 should be 70. And then I'm going to do the lower half. So below 80, 1, 2, so 1, 2, 3, 4. So my Q3 is 90. Okay, so now what I need to do is follow my, where I take 1.5, I'm going to do 90 minus 70. Remember, that's our interquartile range, so that's going to be 1.5 times 20. So if I plug that into my calculator, it gives me 30. And now I'm going to have, so first you have to do Q1 minus 30. So that'll be 70 minus 30, which gives us 40. And then Q3 plus 30. So that's 90 plus 30, which gives us 120. Whoops. Here we go. So now it says, what values would be considered outliers? Between 115 and 120? No, that's not it. So what I need is any number that's above 120. So it's not there, it's not that, not these, not these. So it's E. There are no outliers because I don't have anything that's above 20. 120, I mean. All right.